How to make a tool to check squareness. Okay, before we get started, this tool is 3D printed. And I know you're saying, well, I don't have a 3D printer, Ray, but your public library, at least in Canada, has 3D printers available to you. So you can print this unit for free. You can also get 3D printing services on Facebook Marketplace, Craigslist, and Kijiji. The links to the STL file are in the description. This is a rather long video, so for your convenience, I added this time index table so you can jump back and forth to parts that interest you the most. Okay, let's get started with first using the squareness checker. But before you use it, remember, if you do not have parallelism, you will not have squareness. Therefore, we must check parallelism first. Before we get started checking squareness, you cannot have squareness without parallelism. All faces have to be parallel to the opposite side, okay? Or all faces have to be parallel, period. If your faces are not parallel, you cannot measure squareness. I can't state this enough. Okay, so how is this going to check parallelism? Well, it's a simple fix. All we do is loosen the screw off, lift this guy up, flip it around, put it down this way here. And we're in business, checking parallelism. All parts have been checked for parallelism, and there's zero run out. Okay, so I'm going to zero this out. I don't need to zero it out because I'm checking squareness. So I'm going to zero it out anyways, just to give me a good reference, using this cylindrical square. So I come in, I don't know if you can see this or not, and basically I already did it, so it's right on zero. Having this extended neck here and a 1/4-28 for here is very, very fine adjustment, which is much nicer than the other versions. So when I come in here, I'm going to check squareness this way. I'll have another segment that explains what it is I'm checking and how you can actually get true numbers. So I'm going to come in. The key is I'm going to come in. This piece here is going to roll around, and I'm going to get a 0. And I'm also going to only go 1/4 of the dial. I'm never go more than 1/4 of the dial because you don't want to shock the indicator. So let's try this guy out here. I roll into here, and I don't know if you have parallax error in the video that I'm showing here, but I'm reading at exactly 1 thou. I'm going to flip the block 180 degrees, come in, and I'm reading just a hair under 1 thou. I'm probably about 8/10. So 1 thou because it's above, plus 8/10 because it's below. If they were both above, then it would only be 2/10. But since it's 1 thou above and 8 below, that's 18/10. Divide that by 2, that's 9/10. So therefore, this block is out of square 9/10 this way. Now let's try it the other way. Well, it's out even more. So we go here and we're out, I'm going to say 16 there, 16 above. And I come down here and I'm 16 below. So 16 plus 16 is 32. 32 divided by 2 is 16. So you're at 16/10 out this way. That's a failure for this block, unfortunately. Now it's possible that it's only on this for squareness, and if I flipped it over, I'd get a different number. A couple things you want to remember is you want to be the maximum height that you can on your workpiece for checking squareness. I do not want to check squareness this way, going from here to here and here to here. You always want to check the highest that you can be out from here to here. And you have to get repeatability. So if I'm doing this and I'm getting a number and I come around and I don't get the same number when I'm going each time, indicators are fussy, but you have to have a super rigid setup if your setup isn't rigid, or if this could lean, or you got any tilting here at all, you won't get a repeatable number. If you don't have a repeatable number, then your numbers are completely out. You can't trust it. And I know that this block is out because we checked it on this guy. Okay, so out in the shop, we need to protect these in a little bit different of a way. If you take a look, we have these nice little holders here that are molded or made to fit the exact profile, so they can't slip off and they won't fall down by themselves. And we also, some people will say, hey Ray, you have a wire on here that's some kind of anti-theft thing. No, that's not an anti-theft thing. What it is if it falls off of here, it won't land on the floor because the wire's shorter than the distance to the floor. And it protects the most important piece, the indicator.
Now that we know how the unit works, let's try assembling one. Let's start off with taking a look at a really cool 3D rendering. If you take a look, the 1, 2, 3 block isn't there, and also let's zoom in and you'll see that the spring isn't there as well. And some of the clips and bolts are missing as well. But you'll see that in the upcoming assembly video. Let's flip it over. That's what the bottom looks like. You'll see the 3 bolts. And that's about it. We gathered up all the parts, and this is what it looks like.
Okay, so we are going to assemble this guy today. As you can see, I have enough to do 4 of them. So let's get started on assembly. We'll start with the base. Everything has been deburred, tapped, and reamed already. There wasn't much material in here. Some of the improvements over this year, the 2024 model, as compared to last year's model, is I blanked out the bottom. I don't know if you'll be able to see it or not. The inside here, there's no holes going through, so it sits in. And that's really, and there's a couple of those minor things, but not enough to really mention. So let's start assembling this guy. So we're going to put our 1, 2, 3 block inside first. The 1, 2, 3 block does nothing as itself. What it does, it adds weight, and it allows the center of gravity to be lower, because what we want is we don't want this thing tipping and falling over with an expensive indicator in it. So we're going to take our small set screws here and put them in. I believe they're probably 1/4 by 3/8 maybe. Just as long as they fit all the way in and they're below this surface. They can be any size length as long as they're below that surface. We don't want to put these in too tight, so just finger tight, as long as they're tight enough to not allow the 1, 2, 3 block to come out. That's all you need to do, and it's not like we're going to be tossing this back and forth in the shop. Now we can turn around and we can either do our feet. Now we'll put our feet on this time. Take a little screw here. Now, if you take a look, you say, well, why are you putting these bolts in and they got scratch or imprints on the head? What we're going to do is we're going to sand them off. This is stainless steel, so it won't be that bad. These guys in. Again, when we tighten, we don't want to tighten them down too much, okay? You don't want to ever hear a crack, because that would be bad. You're going back and reprinting this thing. So now we're going to put our front piece in. This is a stainless steel washer. It's for a 1/2 inch. Just as long as this diameter is correct, you can use any thickness washer you want, because it has to fit into that radius here. We'll put our crown on top, put our nut inside of our crown, like that. And I'm really bad for dropping stuff, so I'm going to put my thumb there. Then we're going to take our bolt, our 3rd leg, which I'll explain in a second. Give that a bit of a tighten up. Okay. Now if we take a look here, do you see how this protrudes out? That's exactly what we want. Now we're going to take our arms These are 1/2-inch drill rod. You can make them any size you want. So if you have really tall things you want to check squareness, make these really tall. If you're only doing short stuff, you can make them shorter. Sure they go down all the way. Now, what I should be using is 1/4 by 1/4 set screws. Keep in mind, the size that these are 3D printed, all of these screws, because I like 1/4 20, you can replace all of them with 6 mil. Not a problem. You shouldn't have any problems. Finger tight only. You don't want to hear any cracking. Cracking's bad. And the pressure will hold these in. You almost don't even need these. And that's our base assembled. Now I will go through and we'll talk about, I might as well do it now. There's 3 here, so it's like a 3-legged stool. It'll always be flat. We're going to take some sandpaper and sand down the bumps here. So we have that guy there. So now let's assemble this one. This is our mid plate. This has already been deburred and cleaned up. Now I didn't clean anything inside here. I don't know if you can see that or not. There's some squigglies inside of here. And that's natural because you're kind of 3D printing in the air. I never cleaned any of this up, but I reamed these holes and I tapped these holes and I reamed this hole, which is 1/4. So we'll put this guy together. This here is your arm. This is your mid plate. This is your arm. Your arm has one tapped hole that goes all the way through. It has one reamed hole here, and it has this little flat here. I filed down a piece of aluminum so we can put it inside here. Now normally I would use like an epoxy or something like that, or some crazy glue, but since there's a spring on the bottom, spring goes into the bottom, there's always pressure on it, I thought a little bit of 2-phase tape would work just great. Pull that off there. Oops, got a little mess on our 2-phase tape. Doesn't matter. Put this into our hole here. And all I did is go to the bandsaw from a larger piece, cut it down, and then filed the edges. I didn't put it on a mill or anything, so there's really no machining involved in that either. So we can take our spring if we want right now. Standard spring here. Oops, this one's here. And we can put this guy onto the bottom. Before we do that, I want to talk about these washers. There's always a radius on one side of the washer and a square. So these are stainless steel quarter-inch washers. What we want to do is have the radius go to the inside. So radius to the inside, radius here to the inside. You don't want the square on the inside. There's not a lot of clearance between these two pieces here. Okay? So then, we'll take our dowel pin and just push our dowel pin in and line everything up. Take a little bit of finessing. Don't want to go too far. I think I went a little too far there. Put it back. And there is no wiggle room in here at all. Now we can push this up. Take our spring. There's a seat for the spring, and there's a seat for the spring there. Put our spring in and compress it. Snaps in, and we're good to go. We need to assemble our tri-nut first, or tri-knob. Has 3 bumps. That's why I'm calling it a tri-knob. We'll try and get it to fit. Now, because this was 3D printed down, there's some edges here. So you want to make sure that you have deburred this, and this one wasn't deburred. So clean it out. If you take a knife or a deburring tool, it cleans it out relatively easy. So I'll just use this screw or this nut here to push it in. Once that guy pushes in one time, you've cleaned off the small burr that's on there, and it's fine. Put the screw in from the other side, pop this up. Because it was printed down, inside here is printed into outer space, so it's a little tough. So now we're going to stick this guy inside of here, push that through, pull it out, and this one here that's a little thicker. Okie dokie. It's much easier to assemble when you're leaning over a counter instead of doing it out here. So now this guy here just pushes the end cap inside. And you might have to tap on this one a little bit because it's a bit tight. So push on it. Something a little flat here. Couple little taps and nice and flush. Vanity Ray 24 for 2024. So we'll turn around and put our screw inside. This can be a little tricky, so if you put your nut inside first, or sorry, your bolt inside first, clean out any burrs you got in there. Set that up. Set this guy inside. Have it start to thread, and then just pull upward, and we're good to go. And that guy's fully assembled. You have about 3/8 travel here. This has been extended, so it's much finer, and also the 1/4-20 has been changed to a 1/4-28. So it'll take much more travel to get this guy to go up and down in its movement. So it'll be a much finer movement. So if you see this guy here, see? Nice and easy, spring tension. Okay. And all the parts will be in the description. Now, for the front here, we take our 1/4-20s and put them in. And what I've been able to do on all of these guys is I can just directly put my indicator in without having to drill or do anything with this hole. It prints nicely, and that's on the old printer that's like 6 years old, 5-6 years old. That guy's there. If we really, really want, we can do the full assembly. You need to keep in mind this is plastic, so it's very, very easy to snap. So when we put these guys together, we're only putting them together finger tight. Because this is a spool, we're probably going to fill the nuts or the screws here with an epoxy or something, just to prevent someone from taking this out and using it somewhere else when it's designed for the squareness checker. I had it set aside and I put it away by accident. Push this guy all the way in. See how short it is? It's only a short one. Now all you need to do is take the cap. It says 24 on the back of the cap. Put it inside. Push it in all the way and it locks in. Nice good fit. Then you can turn around and use this as your lock. Now on all of the mating screws, if you take a look, I've ground the edges off so it's smooth, because if not, it puts ridges. It'll put score marks inside of here and it'll make it difficult for it to slide up and down. Okay, so I'll put this in only 1 or 2 threads at a time here. Now I'll put this guy in here. Excellent. It'll lock in place. Okay, let's assemble this piece now. Before we do that, I want to talk about these pins. These are actually recycled pins. I'm using them from another piece. So they had some rust on them, so I went and polished them on the lathe with sandpaper. Then when I went to put this together, it was like chunking as it went down. I said, no, I want this to be nice and smooth. It's supposed to be like a bearing surface. So I took some Scotch-Brite and then rubbed it up and down in the direction that I'll be traveling. So this guy actually, when you put this on here, is super smooth. No issues. When you're at a spot where you're done, you just hit the lock, turn the lock in, and boom, we're good to go. Then you can adjust this head up and down. That's this guy assembled, fully assembled. Now we still need to sand the tabs off here. So to do that, I'm going to use 2 different grits of sandpaper. The rough one, obviously going first. that only took like 30 seconds, so they're all smooth now. But I want to make them a little bit smoother. So I'm going to switch over to a finer grit sandpaper. Beautifully smooth. And that is this guy fully assembled, ready to go. Now I just have a couple more to do.
3D printing. This really doesn't have much value except it shows the orientation of which it's been printed, and it's pretty cool video. Here's a good example of a good print gone bad. Well, it happens sometimes. Here's an example of a good print all the way through. And if you see, we print these on end. The design concept.
Okay, welcome to the design portion. This here was my first idea. A lot of criticism, and I mean a lot of criticism. The idea that I had was that you'd have two posts going up and down with 3 points, and I wanted to make it as 3D printed as possible because Squareness checkers, as you know, are extremely expensive. The ones that we had at the college, I think they were like 1,600, just a crazy number. And then, yeah, they'd disappear. And if I 3D printed something, it wouldn't disappear. So this was my first one that I created, and we used this one for a long time. It got a lot of criticism, but it has all the functions that I want, but it could use a lot of improvement. So first of all, it has almost no weight to it. So it made it easy to tip over, and it was harder to get a good feel. The plastic was lower quality in this one from one of the original printers. But yeah, it's not bad. It's awesome for a first off. Then we upgraded to the full metal base because this was too light. So I CNC'd this, and it moved away from my core principle. The core principle is to be able to 3D print this, give the files away, and then everybody can print one of these guys and be able to check squareness. Because as an apprentice or as a person starting out or a hobbyist, to be able to make sure that you machine something extremely square is important. And I wanted something to look nice and be functional. So this was my second option. Then we moved up, made this guy here a little bit more ergonomical, and from here, from this version, we upgraded and changed because I only had this little piece here. And if you look, there's just a tiny little spring. Now keep in mind, this guy's been used for a few years, so things wear out. Also, if you take a look at the holder, it has a teardrop shape that I thought, oh, I can put every kind of indicator in. No, you don't want that. You want your indicator to be rock solid so it can't turn or nothing like that. Once you set it and forget it, let it be done. So then I thought, okay, let's change from having the spring at the front to moving the spring to the back. See the spring, how it's all discombobulated? Okay, that still works. And then we use our finger here on the knob on this piece here. Not a problem. And then we went into a single point here where it's just a circle with a single point pushing in. But this was pretty weak. Then we moved on from this style to creating this style here. I was still using the machined base, but the problem with that is you had to get the CNC program, and then it was more involved. So I needed something to turn around and say, I need the weight on the bottom, but I also wanted 3 points on the bottom. So to come up with this next version, to get rid of this guy here, this guy became a solid. So we have this guy here, and the springs had seat points. I don't know if you can see that or not. There was a seat point here, and there was a seat point in here. And it's a rear spring, nice and strong. Then we changed the front here to an offset and 2 screws. This was a really good model. And then this here is the safety clip.
so that if it were to fall off the table, it wouldn't land and break the indicator. So then the revolution came. No more CNC base. We have a lot of 1, 2, 3 blocks. We can put a 1, 2, 3 block inside of here, and that weight would be enough to hold it down. So then we have 3 points of contact still. Here, this base is widened out, so the wider the base, and it also gives you something to grip onto, which is nice. And instead of having this guy CNC'd here, we're using a washer. So basically, the newer units come, you need a 1/2-inch washer, maybe 5 1/4-inch bolts, and maybe 5 set screws, 4 set screws. You can put a set screw in here too. I got rid of the knob on the next version because it wasn't worthwhile having. And on this guy here, to make sure this doesn't move back and forth, we have 2 washers in here. And also to prevent wear down here, we incorporated a wear plate. But the problem here, this is a nice slim profile, so when I go to turn the knob, my hands hit. So there's a few things to improve. So then 2024's version here, we have a longer neck, which really slows the amount down that you screw in here. And one of our viewers commented, say, hey Ray, you keep mentioning 1/4-20, why don't you use 1/4-28? I'm like, oh, I never even thought of that. Also incorporated a safety string to go into here. If we can see it. There you go, right there. Safety string to go in there. Set screws here, and then I also included set screws here. So on this one here, I believe we have 6 set screws. 3 bolts on the bottom, and then just 1 bolt here on the side for locking the head to move it up and down here. We also have a bolt and a spring and 2 washers and a 1/4-inch dowel pin. That's basically the hardware you have, and 5 3D printed pieces. It's not bad.
Downloaded files PDF and STL. The link to these files will be in the description. So if you scroll down to the bottom of the description, click on the link and it'll redirect you to the downloads file. You don't have to put any information in. It's not going to ask you anything. It's just the files being uploaded to your computer. If you don't have a 3D printer or don't know how to use a 3D printer, that's not a problem. Most public libraries have 3D printer access for you. You can hire somebody to do it for you from Craigslist or Facebook Marketplace. If you have any questions or comments, please leave them in the comments section below. Thank you for watching the video. If you got any value out of this video, please like and subscribe. It's much appreciated. Have a good night.